Okay, today's lesson will be kind of short, but it's very important. Um, and then you have time to practice, okay? Now, we will first take a look at here. Now, for the past couple of lessons, we learned about how to simplify radicals. And then yesterday's lesson, we talked about complex number, or more specifically, the appearance of the I, the imaginary number, right? So now we're saying, all right, so it's all good and well when it is in the numerator. So what happens if it's in the denominator, right? But before we talk about the imaginary numbers again, let's take a look at these old problems that we had in the past. So the first question here is, what is the problem with the following numbers? Now, you might have some recollection of your teacher saying that we cannot have any kind of square root in the denominator, okay? If there is any kind of square root in the denominator, then we'll say, oh yeah, you have to rationalize it. So let me first write down the word rationalize. Okay, rationalize. All right, so we're going to do the rationalization process in just a little bit. Okay, now the problem is this: do you understand what the word rationalize means? And even further, do you know why we have to rationalize? Or we ask an even more simpler question, which is, where does the word rationalize came from? Where does it come from? Okay. Now, as of the taping of this video, I am, this year is 2022, right? So I am going to be 38. I'm going to be 38, but I'm now 37 years old. And I would say I learned about rationalization about the same age that you are right now, about 15 years old. And I would be very honest with you that I had no idea why. I knew what rationalization means, but I had no idea why we do it until last year when I was 36 years old. Okay. I mean, I could have Googled it. I could have, but I didn't. So it's on me. Okay. So if you know what rationalize means and why, it will be like you are at least 20 years better than I do. Okay. So that's my perspective here. So you are 20 years better than me. Okay. If you understand the why. So let's talk about the why. Like, why is it a problem that that we have a square root 2 in the denominator? So here's how it works, all right? So if you have, well, first, what is square root of 2? Now, square root of 2, if you look at a calculator, square root of 2 is something like this, okay? It's a decimal number, and it keeps on going, and it's not going that far because I change a setting. If I say, oh, so just float 6 digits, and if I say, go ahead, float 12 digits, then I do the same thing again. You can see a lot more numbers, and it just never ends. So in terms of the meaning, okay, well, if you divide by a number, like you're going to divide by 5. Now, if you say divide 5 by 2, I would say, oh yeah, it's easy. It's 2.5 because you split the 5 into 2 halves. That's easy. That's easy to understand. We can visualize it. But if you say, go ahead, split the 5 into how many parts? Into this number, 1.414, like the number on the right, 1.41421356237. Like if I'm the person who splits the 5, then I'm like, I have no idea what you're talking, because I just don't know how many parts you want me to split. Okay, I have no idea. So this is the reason why we say that in the denominator of a fraction, we should never ever have a square root or anything irrational. We should not do that, okay? Because that is just nonsense. We don't understand what it means, Okay, so because of that, we need to find a way to get rid of the square root. And when we say that, a lot of people will be like, oh, I know. Can we just square the whole thing like this? And I would say, if you think about this, this is utterly wrong. Why? Why is it wrong? I thought we would need to get rid of square root by using square. I mean, yes, but not this way. The problem with this is that, well, now let me just go ahead and give you a little perspective, okay? Using a calculator that would help you see the perspective better. 5 over square root of 2. Now, calculator doesn't really need you to rationalize it. It will still give you the number. So if you calculate it, you have this number, right? Now, if you square the whole thing, okay, if you square the whole thing, the problem is, do you still get the same number? You don't. And that's a problem. You cannot just square something and say, oh, yeah, it's equal to that. Okay, no, it's not. Okay, you can't just square the whole thing. Like, I wish I can square my bank balance so that I can become maybe square a few more times so that I can become a millionaire. But no, it doesn't work like that, right? So we have to find a way so that we can get rid of the square root legally without changing the value, okay? So whatever we get at the end, if we put in the calculator, it should still retain the value of 5 over square root of 2. That's the main idea. So how do we do it? Well, if you remember last lesson or last 2 lessons, remember we said something like this? What is square root 2 times square root 2? Oh, I know. It is just 2 because, well, square root 2 times square root 2 is square root 2 squared, right? And square root, they cancel each other out. So we can utilize this idea, but with one little thing that you have to take care of, and that is we can only multiply by a number 1. We cannot change the value. And we know that by multiplying by 1, everything remains as itself. But this 1 right here can be presented in many ways. And for us, it will be this way. It will be root 2 over root 2. That's 1, right? We're multiplying by 1. And why? Now, I'm going to tell you this. If you don't invest this following 10 seconds to ask yourself why and answer yourself this question, you are going to lose track of why you do things, and it will not end well. Okay, so please ask yourself, why? Why are we multiplying root 2 over root 2? Well, because when we multiply by fractions, we multiply across, right? And as we multiply across, if you focus on the denominator first, we would say, oh, root 2 times root 2, it's 2, right? Now, we will multiply the 5 and root 2 in the numerator, which is 5 root 2. And what was the major problem that we had earlier? The problem was we had a square root in the denominator. Do we still have a square root in the denominator? We don't. Do we fix the problem? Yes. Now, just to prove that this 5 root 2 over 2 is retaining the same value as 5 over root 2, I'm going to show you the calculator, okay? So remember 5 over root 2, which was the one with 3.5355, all right, now. So what about this? 5 root 2, close parentheses, divided by 2. All right, take a look what that value is. See? You have the same value. So this is why we do our, how we do our rationalization. We basically are multiplying by 1, but this little 1, it's showing up as root 2 over root 2. And why we do that is because we want to get rid of the square root and without changing the value of the original fraction. Okay, so that's the key idea. So let me just go ahead and take away the highlighting. Okay, so that's really what you do. Now, what about the number on the right? All right, so if you look at this, So you're like, oh, you may have a little impulse and be like, oh, I know what to do. I know what to do. All right. And you'll be like, oh, let me go ahead and do this. Well, it's a good try, but unfortunately, it won't help you solve the problem. It won't help you get yourself out of this trouble, because if you do this, well, in the numerator, you would have 2 times root 3, which is not a problem. Well, what about the denominator? Now, this root 3 might be getting the complete attention in your mind, but don't forget, there's an addition right here. There's a little 1 plus root 3, and that means you've got to distribute. So if you only multiply by root 3, then you have this. So this is what it is, and you still have a square root down below. And we're like, that doesn't work. So what do we do? What do we do? Okay, how can we get rid of the square root in this kind of scenario? Well, in the last lesson, I emphasized something. I said, hey, please make sure that you know this. And let's just go ahead and quickly go back to yesterday's lesson. And let me point out what I was talking about earlier. Remember yesterday we were talking about like simplifying these I things, right? And I said, hey, you got to make sure that you know how to do this. You can do this by FOIL, and you can do the smarter way. You can do can you recognize that it's A plus B, A minus B? And the reason why I gave you this little hint is because it is what's coming to you today. Okay. Now, understanding that A plus B times A minus B would give you A squared minus B squared. And this is my renewed understanding or appreciation of this little circled thing. A plus B times A minus B is equal to A squared minus B squared. So I'm going to show you something. Okay. Now, first, I'm going to rewrite that over here. A plus B times A minus B, it's equal to A squared minus B squared. And why did I say I got a renewed appreciation of this little equation is this? Don't we want to square something, but we cannot square the whole fraction out of nowhere? We have a way to tackle this problem. So this whole thing is like our tool. The tool is to do this. We are still multiplying by 1. This 1 would appear as 1 minus root 3 over 1 minus root 3. And why do we say 1 minus root 3? Because it's like A plus B times A minus B. That's how you look at this, okay? And what's the benefit of doing so? Well, we know A plus B times A minus B would give us A squared minus B squared. What's A? Oh, it's the 1. What's B? Oh, it is the root 3. Okay? And by doing so, hey, what do we have in the denominator? We say, oh yeah, the denominator, let me see, 1 squared is just 1. Root 3 squared, that's just 3. And you can see that the square root, it's gone. There's no more square root in the denominator. And that's how we can simplify. How we can simplify or rationalize the fraction so that there's no more square root in the denominator, and hope the 2's are getting your attentions. And we will simplify it. So you would have negative of 1 minus root 3, which brings us to negative 1 plus root 3 as our final answer. Okay. Now, so let's do a little quick recap here. What did we do? We still want to square, but we cannot multiply by just root 3 here. We've got to do something, we can multiply something so that there would never be any square roots in the denominator. So we came up with this little tool. We realized that we learned something, we can use it. Now, by the way, there's a term that I want you to learn. Okay, so these two things, 1 plus root 3 and 1 minus root 3, they are known as the conjugate. Okay, they are known as the conjugate of each other. 1 plus root 3, 1 minus root 3. So we will simply say, oh yeah, we'll just multiply by the conjugate of 1 plus root 3. Okay, on top and in the bottom, in the numerator and also in the denominator. So with this tool or this skill, we are able to remove the square roots in the denominator, and that is going to be very lovely. Okay, and in the next video, we will see how we can apply these concepts that we learned back in Algebra 1 or geometry to our new content, the imaginary number, because the I is essentially a square root of -1, right? And we do not want a square root underneath the in the denominator. So how are we going to do it? So let's go to the next video.